Well, let's continue. Well, you can just use this table not only for the seventh worker, but all workers. Basically, calculate marginal productivity of, for example, seventh worker is the difference of production level of with the workshop with 7 workers and workshop with 6 workers. In this case, it is 10, and you can do it for all workers, and you can get this type of result. One thing actually I should talk on this, the marginal productivity, is this. The concept itself takes the worker's representative. So we assume a worker we talk on when we are talking about 100 workers or 101 worker is an average worker. So this 101st worker, in that sense, in this model, is not different or more lazy than the other 100 workers. In other words, for example, if you have 101 worker and take 1 worker away, whatever worker you take away, the production level falls from the 1008 to 1000 basically. This doesn't mean it's that way in the reality. In reality, I mean, 1 worker might be more productive than the other, or 1 worker might be even more critical than the other. But here in our model, we assume the workers are average, basically. When we take an average worker away, or when we put an average worker in, what happens is what the model is showing. So in that sense, fall of the marginal productivity, the conditions that determine marginal productivity is not the characteristics of the worker, but rather the conditions in the workplace. How much productive an average worker can be under the conditions of a workplace which has already 100 workers working in it. Let's go further. So now, this law is very much in parallel with the law or principle of diminishing marginal utility. So this one is called law of diminishing marginal productivity. It basically states this: when you have a workplace producing a service or a good with constant capital, when you add more and more workers to it, when you increase your working, the number of workers in it, initially adding more workers will increase the marginal productivity, the amount, the additional product each new worker is bringing. That's because when you have more workers, they can divide the jobs between each other. They can basically specialize on different tasks and also use the capital, the machinery around them more efficiently. So if you have 1 worker who might go from one machine to other machine, might be less efficient than having in front of each machine a separate person. So initially, because of this more efficient use of the machinery and the infrastructure, and potential way of cooperation, between the workers, division of labor and cooperation between the workers, the productivity of the marginal productivity of workers initially increase, because when 1 person can produce 5 minutes, when you have 2 person, second person, instead of producing himself 5 minutes, it might make that new worker will make also the first worker more productive, and of course that worker will also be more productive than the first worker working alone. So the third worker might make the first and second workers more productive and be more productive than first and second worker working only as 2 people. But there will be a point where this potential of increasing the more efficient use of the machinery and potential of having more collaboration might be exhausted. And at that point, I think the more worker will, uh, increase production level at decreasing quantities. In other words, the marginal productivity will start to decrease because we already have people in the station. New worker might still fasten up things, but not so much because already you might have enough people that are in front of all machines. Maybe another worker might for example, um let other workers rest and work faster, or maybe you might try to build connection between different workers. Carry certain stuff between one machine to another, while this might be done by one worker. So there might be still opportunities to increase the production level when you add another worker, but each worker now will decrease the production level at a decreasing rate. There can be a point when the adding new worker doesn't increase the production level at all. In that case, marginal productivity of additional worker will completely be zero. As long as the new workers increase the production level to some extent, in that case, the marginal productivity of the last worker is still positive, even if it is decreasing. But if marginal productivity of the last worker is zero, in that case, new worker doesn't increase production at all. In that case, this new worker whose marginal productivity is zero is called secretly unemployed worker. You cannot specify which worker is secretly unemployed, but the fact that marginal productivity of last worker is zero, which means actually taking one average worker from the working force, doesn't change anything. Production doesn't change the production level. That means actually there are some workers who are secretly unemployed in the working facility. So, as you see, initially the slope of when you increase workers by one, the production level increases, which means slope of this line is increasing. And at some point, however, the increasing the production level further still increases the production level, but at decreasing rate, which means slope is decreasing. But as long as the marginal productivity is larger than zero, marginal product is larger than zero, still the total shoes produced increases as you add more workers. And this is the marginal product. How marginal product change when you add more workers. At first, it increases up to the point when, and as long as it increases, basically the total shoes per worker line for different sizes of workforce line has an increasing slope. And after a certain point, marginal product is decreasing, and after that point, you have a decreasing slope. Now we can come to marginal cost. If the labor costs are only variable costs, basically, we can turn the marginal productivity to the marginal cost. Of course, here will be one problem we might have is might be if one worker, you can hire only a single worker, and basically that single worker might add, for example, 10 TVs, additional 10 TVs to the production level. In that case, you can only define marginal cost for those 10 TVs as a whole. Although the marginal cost itself is actually defined, as you see here, in this way. It is the cost that is added to for the company when you increase production level by 1 unit. So if you instead of producing 100 TVs, you produce 101 TVs, and if producing 100 TVs costs $1,000 and producing 101 TV costs $1,015, in that case, marginal cost of producing 101st TV is $15. As I said, I mean, this finding marginal cost for one TV might be difficult if you need to hire workers one by one, and basically you cannot that one worker basically increases the number of TVs at a level more than one, maybe two, three, four, five. In that case, you can only find marginal cost, average marginal cost for all those 5 TVs. But in the microeconomics theory, we assume that labor is infinitely divisible, so you can actually not buy one worker, labor power from one worker for full time. You can also buy half of labor. So in that case, I mean, if for producing an additional 101st TV, you might buy 1/6 or 1/12 or 1/2 of the worker's labor power, which might be done by hiring the worker for example, I don't know, 2 hours or 3 hours, maybe. And marginal cost is, of course, change in variable cost. Why it is so? Because basically it shows you how much the cost increase when you increase production by 1 unit. The only cost that can increase when you increase the production level by 1 unit is the variable cost, since fixed cost is independent from the production level. So marginal cost always shows you also the increase in the average, the variable cost level, total variable cost level. It also shows you, of course, the increase in the total cost level, but basically the fixed cost part is fixed anyway within the total cost. Well, again, this is the case where you can see how we can translate the marginal cost and marginal productivity. It's a little bit strange because, again, we can only calculate the marginal cost for a multiple number of goods here. The good we are talking is here the shoes, and basically you can see the marginal product for different number of workers. And for example, when we have we are producing, we have 2 workers instead of 1, the marginal product is 40 in this case, and marginal cost of this additional 40 shoes can be calculated by dividing the wage of this worker, which is cost added by in order to increase the production level from 30 to 70 to add this additional 40 units. You basically need to pay the wage to the worker, which is $100. So this $100 is paid to the worker, and as a result, 40 additional shoes are produced. So the marginal cost per shoe for this additional 40 shoes, in this case, $2.5. Of course, again, as I said, we are assuming here I need to hire workers by one, and it is not possible for me to produce only 20 of this additional 40 shoes, or producing 50 shoes. So when I get this second worker, and I mean, I have already paid the money for this worker, and this worker, if I will produce only 50 shoes, I won't get the worth of the money I pay for this worker. So in order to get benefit of this worker in full sense, I need to produce 40 additional shoes, or 70 shoes in total. Again, in microeconomics, especially when you go to the advanced levels, you see it more clear. It's assumed, I mean, workers don't need to be bought by one by one. They can also buy 1.256 units of labor, for example, by maybe employing the workers for part-time. So what can we talk now? We will concentrate on the marginal costs in the next part. So see you in the next part.